Hey, this is Mr. Mitchell with another video. Today's video is going to be on something called momentum. You know, we've talked recently about speed and velocity, and we said that velocity has a direction to it. There's another quantity that has direction to it, and it's called momentum. A bus and a car, for example, here, if they go the same speed, could be any old speed, which one is harder to stop? Well, it's going to be the bus, of course, because the bus weighs more. In fact, the bus weighs a lot more than this little bitty old car and would be a lot harder to stop. A train, for example, is so heavy that even if a train person sees someone on the track, they can't stop it in time because of the momentum. So if the car, however, let me give you another situation. If the car were going very, very fast and the bus were going very, very slow, then that's an instance when the car just might be harder to stop. Say the bus is going 2 miles an hour, like somebody's walking right beside it, and it's just creeping along. The bus driver could probably put on the brakes and stop faster than an 80-mile-per-hour car could. So there's more than just the weight of the vehicle, which would determine how hard it is to stop. There's also the speed at which it is going, or the velocity at which it is going. So you can probably imagine that we're coming up to a formula here. There is a formula for momentum, and momentum is what makes it hard for either of these to stop. The formula, of course, is right down here. P is momentum. Momentum equals mass times velocity, and you know that makes sense. Whenever they're going the same speed, the thing with the most mass is harder to stop. Whenever there was one going really, really fast, it was harder to stop if the other is going really, really slow. So that's the formula for momentum. And simply, the weight or the mass times the speed or the velocity. The momentum has a direction just like velocity does, and its unit is kilograms times meters per second. So if you have kilograms times meters per second, well, mass is in kilograms and velocity is in meters per second. And I have seen this written like this here, and I've seen it written where you have the kilograms out to the side, kilograms times, and then the meters over a second. But that's the same thing. If you have kilograms out in front here, then that's the same as saying kilogram over 1. Because any quantity you have that's not in a fraction is just like saying it's over 1. So if you see it this way, or if you see it out ahead of the meters per second, it doesn't make any difference. Well, I think the best thing to do with momentum is look at some examples here. If we have a 100 kilogram football player that runs at 10 meters per second, what is his momentum? First thing we need to do is remember the formula. The formula is P equals mv, mass times velocity, which equals, the mass is 100 kilograms, and we will multiply that. You may remember if you put in parentheses, it's the same thing as multiplying. Multiply that times 10 meters per second. And that's exactly what we're looking for, kilograms times meters per second. So all we have to do is multiply this 100 times this 10, and hey, that's a pretty simple one. Looks like we will have 1 with 1, 2, 3 zeros. Oh, sorry. So that is 1,000, but hey, you got to remember to put the unit on every kind of calculation we have. Kilograms times meters per second is what you have. So 1,000 kilograms times meters per second. See if that football player has more momentum than this frog. No, this frog has an incredible amount of momentum, which is kind of strange. Maybe I just made these figures up. this frog has a lot of momentum here. Now, look what I have in here. It says a frog weighing 900 grams has a velocity of 10,000 kilograms times meters per second. That's not right. That is momentum. Momentum. So what we're looking for is the velocity. I had that written down wrong. So how do we do this? Well, we take the formula, and you've seen this before. Take the formula, and we are solving for velocity. So in order to do that, to isolate velocity on one side, and to do that, we divide it by everything else. So in this case, divide it by m. But whatever you do to one side, you have to do to the other. So the m's cancel out here, and we're left with velocity equals p over m. And yes, you can turn it around. Velocity equals p, which is momentum, over m, and which is mass. P is 10,000 kilograms times meters per second over 900 grams. Whoa, before I put 900 grams down, it's not 900 grams. It is 900 grams, but kilograms is what this is supposed to be in. So we have to convert this to kilograms, and you can do this down at the bottom. And this is one where you could probably just figure this out in your head. But if I have 900 over 1, and that would be 900 grams, I'm going to put the grams diagonally. So I put 1,000 grams here equals 1 kilogram here. The grams cancel, so you're left with 900 on the top. 900 times 1 is 900, divided by 1,000, which is a simple 0.9 kilograms. So right up top here in the formula, you put 0.9 kilograms, and I will go to my handy dandy calculator here. So 10,000 divided by 0.9. Let's go with 10,000 divided by 0.9 equals, whoa, what a figure, 11,100.1111. So we'll not go with all of those. So it's, oh, what am I doing here? I'll get this off the screen. So that means we have 11,100. What is that going to be in? We found velocity. So velocity is in what? Meters per second. So that is one fast moving frog. Maybe I didn't use very good accurate figures there. But anyway, that's just as figures to plug in the formula. What if your brother weighs 120 kilograms? He runs 40 meters in 5 seconds. What is his momentum? Well, let's see what the momentum formula is. P equals mass times velocity. We have the mass, kilograms, but we don't have the velocity yet. Velocity is in meters per second. So we need to go ahead and find the velocity. So velocity equals distance over time. Distance is 40 meters in 5 seconds. So 40 divided by 5 is going to be 8 meters per second. Okay, so now we have the velocity also in 8 meters per second. So we'll go P equals mass, 120 kilograms, times, I'll just put the times symbol here, what is that, 8 meters per second. So go to my calculator, 120 times 8 equals 960. 960 what? Kilograms times meters per second squared. That is the momentum. Or not meters per second squared times meters per second. So that is your answer there. Hey, let's look at this one. If a car has a momentum of 10,000 kilograms times meters per second and a speed of 500 meters per second, what is its mass? Oh, we're finding its mass. So let's get the formula for momentum, because I think we have everything else. We need to isolate mass on one side. So to do so, we will divide both sides by V. Remember, you're doing this to isolate mass on this side. That will cancel the V's out, and you have to do the same thing to both sides. So this means mass equals momentum over velocity. I'll write that down there. Momentum over velocity. So let's see what we have. P, the momentum, is 10,000 kilograms times meters per second over 500 meters per second. So in finding the mass, what value are we looking for? I think we're going to be looking for kilograms. Notice that the meters per second will actually cancel out if you forget. This will cancel out with this. So this is just a matter of plugging it in the calculator. This is the same thing as 5 into 100, I noticed. So 500 into 10,000 should be 20. Let me make sure that I'm right. So for a division, we have 10,000. Remember the top number goes in first, divided by 500. See if I got it right, that it is 20. Oh, I hit the wrong thing. Hit that correct button, the C instead of, now I had to hit C. Pardon me while I lose my brain. Maybe I'll get it right this time. 10,000 divided by 500 equals, hey, I was right, 20. I should have just put 20 in the first place. But hey, it doesn't hurt to double check your answers. So that would be 20 what? Well, since we're finding mass, we are going to look at kilograms. We do have a kind of an instructional slide here. Imagine two cars of different masses. Say one of these weighs more than the other. Maybe the green one weighs more. Have a head-on collision. We can predict what will happen after the collision because of the law of conservation of momentum. This states that the total amount of momentum in a system is conserved. If cars collide head-on, the one with the most momentum will push the other. If they're going the same speed, but the green one is heavier, then whenever they collide, the collision will push the other car, the blue car, a little bit this way. Sure, you could even calculate. This one is such and such kilograms going at such and such speed. This one's such and such kilograms at such and such speed. One of them will have the most momentum, and whichever one does will push the other one after the collision. The amount of momentum is conserved. It doesn't just stop both of them unless they have the same momentum, and that's what ends up canceling it out. So I hope you've learned a little bit about momentum.